What if I told you the Big Bang never actually happened? And I mean, not that it happened a little differently than we thought, but that the whole idea of a single localized explosion creating everything is just, well, a complete optical illusion.
Yeah, it is a incredibly jarring thought to entertain, right?
Yeah.
Especially when you consider just how foundational that narrative is to, our modern understanding of the cosmos.
It really is. And I want you, the listener, to just kind of hold on to that feeling of structural whiplash for a second, because I want you to transport yourself back. Think back to your high school science class.
Oh boy.
Right. Maybe you were sitting on one of those heavy black lab tables, the smell of formaldehyde or like Bunsen burner gas is faintly in the air. You're staring at a textbook and you're basically being handed what feels like a completely disjointed patchwork of rules about reality.
Yeah, I mean, it's a remarkably universal experience for most of us.
Exactly. On Tuesday, you were in Earth Science and you were taught one theory for how the Earth formed accretion disks, cooling magma, heavy elements sinking to the core.
Right? Then on Wednesday, you're in a different class, learning a completely different set of rules for how the universe itself originated.
Yeah.
Singularity, sudden expansion, cosmic microwave background.
And then maybe later in the year, you got a chemistry or early quantum mechanics.
Oh yeah, where the teacher basically tells you that absolutely none of the rules you just learned apply at the subatomic level anymore.
Exactly. You're presented with a world that doesn't quite fit together. We are handed these isolated fragments of reality, like a classical physics puzzle piece here, a cosmological puzzle piece over there, a geological one there.
hmm
And we are implicitly told not to worry about the fact that their edges just do not match up.
And the unspoken rule, like the absolute undercurrent of that entire educational experience, was essentially shut up, accept, and memorize.
Yep.
When you raised your hand and asked, wait, how does the gravity that formed the Earth connect to the strong nuclear force holding the atoms of the Earth together?
Yeah.
You were basically met with a wall because the system isn't designed to reward the why. It's entirely designed to test your ability to retain the what.
Which brings us to our mission today. Whether you are a student right now feeling that exact frustration or, a parent or grandparent watching your kids go through that exact same rote memorization grinder, it makes you stop and wonder.
Are the current narratives we accept as absolute scientific fact actually correct? Or are they just, well, the best patch job we could come up with?
Exactly. And today's deep dive unpacks a massive stack of notes, transcripts, and philosophical musings from an author who decided to completely reject that fragmented approach.
The scope of what we're looking at today is just staggering. I mean, the author of these sources isn't trying to tweak a math equation. They are attempting to offer a single, logically consistent model of reality.
Right.
From the absolute smallest resonance in the subatomic void all the way to the birth of entire galaxies, this framework uses one continuous set of rules.
We are exploring a radical, unified framework composed of two interconnected theories. One is called the NKE, which stands for Nichts-Kruste-Etwas. And for our non-German speakers, that translates literally to Nothing-Crust-Something. And the second theory is the SBT, the small bang theory.
The ambition here is to provide a foundational challenge to modern physics.
So let's lay out the roadmap for what we're going to do today. We are going to explore how the NKE and SBT challenge traditional patchwork physics.
Right.
But more importantly, we're going to see how this material serves as intellectual fuel. It's not just about solving theoretical physics mysteries, it's about reigniting the joy of critical questioning and holistic understanding that, honestly, the old educational system so often extinguishes.
We want to look at reality as a cohesive story. But before we can understand this new cohesive story, we basically have to perform an autopsy on the old system.
Yeah, we have to understand why physics got stuck and why we collectively just stopped asking why.
I think to understand that stagnation, we really have to trace the historical search for a theory of everything, or a TOE. Because for centuries, the holy grail of physics wasn't specialization, it was unified understanding.
Right, let's rewind to Isaac Newton in 1687. He publishes the Principia.
Exactly. With classical mechanics and his law of universal gravitation, Newton unified the heavens and the earth.
Oh.
He showed that the exact same force causing an apple to fall from a tree is the force keeping the moon in orbit.
Which are huge.
It was a massive leap, a beautifully unified theory for its time.
But, it had limits. It couldn't explain electricity, and it couldn't explain light.
Right, so
Yeah.
physics kept pushing. Fast forward to the 1860s, and James Clerk Maxwell comes along.
Okay.
He brilliantly unifies electricity and magnetism into one framework, electromagnetism. He even proved that light itself is an electromagnetic wave. But gravity, Newton's domain, and the inner structure of matter were sort of left out in the cold.
And then Albert Einstein steps onto the stage. He completely upends Newton with general relativity, showing gravity isn't just this pulling force, but the actual warping of space and time itself.
And it's elegant, it's smooth, it's continuous. And he spends the latter half of his life desperately searching for a unified field theory to tie his smooth gravity to electromagnetism.
But he hits a wall.
He hits a massive wall because of the quantum revolution.
Right.
While Einstein was looking at the smooth, macroscopic cosmos, other physicists were looking at the microscopic world. And the subatomic world of quantum mechanics just wasn't smooth.
It was chaotic, jumpy, probabilistic.
Exactly. You had particles popping in and out of existence, existing in superpositions. Einstein famously hated this, stating, God does not play dice.
Yeah. So you have a smooth theory of the massive and a jumpy theory of the tiny, and they just fundamentally refuse to talk to each other.
Yeah.
When you try to combine the math of general relativity with quantum mechanics, the equations just break down. They spit out infinities. It's mathematical gibberish.
And this brings us to the 1920s, which is really where the philosophical shift happens in the scientific community.
Okay, set the scene for us.
Quantum mechanics is firmly established, and with it comes what's known as the Copenhagen interpretation, spearheaded by Niels Bohr and Werner Heisenberg. And this is the turning point for our story. The prevailing attitude in physics shifted from a quest for deep, unified understanding to a highly pragmatic, almost cynical approach.
The mantra literally became, shut up and calculate.
Yeah, coined later by physicist David Merman, but encapsulating that exact era perfectly.
I really want to focus on that phrase for a second, shut up and calculate. It's incredible that this became the unofficial slogan of theoretical physics. Like, what does that actually mean in practice?
Well, it basically means, look, the quantum math works. Our predictions are incredibly accurate. We can build lasers and microchips. So stop asking what is actually happening behind the math.
Stop asking why reality behaves this way and just run the numbers.
Exactly. It was an admission of philosophical exhaustion. The leaders of the field decided that asking the ultimate why questions might be fundamentally unanswerable, or worse, just meaningless.
Wow.
And if we connect this to the academic reality of the modern era, the sources we're looking at today offer a scathing critique. The search for a theory of everything wasn't abandoned just because it's mathematically difficult. It was abandoned because, in modern academia, it is basically career suicide.
Let's dig into that incentive structure, because if you're a young, brilliant physicist today, the system does not reward you for spending 20 years locked in a room pondering the foundational nature of reality.
Not at all. The incentive structures in modern universities and research institutions are entirely pragmatic and grant-driven.
Right.
It is far safer and far more lucrative for your tenure track to publish 100 hyper-specialized papers on a tiny incremental subfield than to risk your entire career on a grand, unifying theory that might ultimately fail.
And if you step outside the established mathematical models to ask foundational questions, you are quickly dismissed as just doing philosophy.
And in modern physics circles, calling someone a philosopher is often used as a derogatory term.
It implies you aren't doing real work.
Right, you aren't producing data.
So, bringing this back to the listener, if the top physicists in the world are culturally and financially discouraged from asking foundational why questions, it trickles all the way down the educational pipeline.
Absolutely.
It makes perfect sense that a high school system simply demands that students obediently learn disconnected facts. The teachers are just passing down the culture of the scientific establishment. Don't ask how the Earth's formation connects to quantum fields. Just shut up, accept, and memorize.
It creates a culture of intellectual obedience rather than intellectual curiosity. The current system wants a student who can recite the standard model of particle physics, not one who points out its logical inconsistencies. And this is exactly the crisis the author of our source material is trying to break through. If the traditional, highly complex mathematical approach has stalled out, just look at string theory.
Right, string theory.
It has been mathematically elegant, but experimentally unproven and completely inaccessible for decades. So we have to change our methodology.
We can't keep trying to build a taller ladder if we're leaning against the wrong wall.
Precisely. We need a totally new way of looking at the problem.
Which brings us to the author's deeply refreshing approach. Instead of demanding a flawless, hyper-complex mathematical proof right out of the gate, the author acts like a pragmatic detective. The sources call it an Indizien-Beweis. a circumstantial evidence approach.
The detective analogy is very apt, and it's crucial to understanding how the NKE and SBT were developed.
Okay, break that down for us.
Well, in a criminal investigation, you rarely have a 4K video recording of the crime actually taking place. You don't have the luxury of absolute, undeniable direct proof. But a good detective doesn't just throw their hands up and say the crime is unsolvable.
Right. You look at the blood spatter, you look at the muddy footprints, you narrow down the suspects.
You ask, what properties must the fundamental process of the universe have? Where did it leave its fingerprints? What forces were utilized? By gathering circumstantial evidence, you eliminate mathematical or physical suspects until you are left with the most logically sound candidate.
I love this because it completely democratizes the search for truth. You don't need a supercomputer or a particle accelerator to start asking logical questions about the universe.
Exactly.
But to start this detective work, the author takes a really bold philosophical stance. They dismiss one of the most famous questions in the history of philosophy, the Gottfried Wilhelm Leibniz question.
Yeah, Leibniz famously asked, why is there something rather than nothing? It has haunted philosophers and theologians for centuries. Why does anything exist at all? Why isn't there just an empty, silent void?
And the author of our sources calls this question a complete distraction.
They argue that if you want to find a functional theory of everything, you shouldn't start by doubting existence. The undeniable, observable fact is that the universe does exist. And not only does it exist, it is incredibly stable.
That's a really good point.
Think about it. Despite all the chaotic quantum fluctuations we observe, the macroscopic universe holds together. Matter doesn't just randomly dissolve into the void. The cosmos is the most stable system we know of. That stability is your starting point.
It's like our detective walking into a room with a body on the floor, and instead of looking for the weapon, he starts stroking his chin and saying, well, before we look for clues, let's debate whether murder is theoretically possible.
Right.
No, the body is there. The universe is here. Deal with the evidence in front of you.
And this pragmatic acceptance of reality leads to a crucial epistemological concept in the text. It's an acronym, TAW, or Temporary Absolute Wahrheit, Temporary Absolute Truth.
Temporary absolute truth. I mean, that sounds like a massive oxymoron. Yeah. How can something be absolute and temporary at the exact same time?
To grasp this, we have to step briefly into the realm of mathematics, specifically Kurt Gödel's incompleteness theorems from the 1930s.
Okay.
Gödel mathematically proved that we can never completely and definitively prove a system from within that same system.
Let's translate that for someone who hasn't taken advanced logic. Like, what does that mean in practical terms?
Okay, imagine you are trying to write a completely perfect, foolproof rulebook for a game while you are currently playing the game, and you can only use the language that the game provides you.
Got it.
Gödel proved there will always be truths within that game that cannot be proven by the game's own rulebook. The system is inherently incomplete. So demanding absolute eternal mathematical proof for a theory of everything while we are stuck inside the universe trying to observe it is a fool's errand.
Because we can't step outside the universe to look at it objectively.
Exactly. Therefore, the author suggests we should abandon the arrogant quest for eternal proof and seek a temporary absolute truth.
Meaning, a theory that perfectly and consistently explains all known phenomena.
Yes. If a unified framework can coherently explain everything we currently observe, from planetary orbits to quantum resonance, without internal contradictions and without having to invent magical new particles every time the math doesn't quite work,
Right.
then it holds the status of temporary absolute truth. And it remains the absolute truth until new data arrives that breaks it. It is a highly pragmatic, scientifically honest approach.
It doesn't claim to be the final word of God. It claims to be the best possible map of reality we can draw right now. But here's where it gets really interesting on a psychological level.
Oh, yeah.
The sources point out that many people, even brilliant scientists, actually resist this kind of unified map. They actively want the universe to remain somewhat mystical.
This is a profound observation about human nature embedded in the text. An actual theory of everything destroys the comfort of the unexplainable. People often find a strange solace in saying, well, we will never truly understand the cosmos, or the quantum world is just magic.
Why do you think that is? Is it because if the universe is logical, it puts pressure on us to be logical?
Partially, yeah. A logical, pragmatic theory of everything strips away that mysticism. It demands intellectual accountability.
Interesting.
If the universe makes sense, then you have no excuse for retreating into intellectual complacency. It forces you to engage with the mechanics of reality.
It demands that you actually do the work instead of just shrugging your shoulders. So let's do the work. We've set up our detective methodology. We're looking for a temporary absolute truth based on circumstantial evidence, rather than waiting for an impossible mathematical revelation.
Time to reveal the prime suspect.
Yes. The singular engine that the author claims is driving this entire unified theory. The sources call it the Busfo process.
The Busfo process is the beating heart of the NKE theory.
Yeah.
NKE, again, stands for Nothing-Crust-Something. Nothing-Crust-Something.
Let's unpack that acronym before we go further. Nothing-Crust-Something. What does crust mean in the context of the void?
Think of the crust as a boundary layer, an interface. It implies that from the absolute void, the nothing, a boundary or structure emerges, the crust. And that eventually builds up into the material reality we observe, the something. The Busfo process is the mechanism driving that transition.
And how does the text actually define this process?
The Busfo process is defined as a continuous, infinitely fine, infinitely fast process of self-reinforcing structure formation. And crucially, it is occurring everywhere at once.
Wait, everywhere?
Yes.
Okay.
It is not an event that happened once billions of years ago in the past. It is the active, ongoing engine of reality right now.
Okay, let's slow down. Infinitely fine, infinitely fast structure formation. That can sound like abstract word salad. We need a mental model here.
Fair enough.
The author uses a brilliant analogy in the notes regarding a guitar string. Let's talk about that.
It's an excellent way to visualize it. When you pluck a guitar string, the string doesn't just vibrate in any random chaotic way.
Right. It vibrates at very specific, stable frequencies based on the length and tension of the string. You get distinct notes.
Those are standing waves, or stable resonances. Now imagine that the Busfo process, this constant, infinitely fast churning and structure building, creates a three-dimensional instrument.
Okay, I'm picturing it.
The sources call this the Busfo Geflecht, or the Busfo network. It's like an infinitely complex 3D guitar string.
And inside this 3D instrument, only very specific, stable 3D vibrations can exist, just like the 1D guitar string only allows certain notes.
Exactly. And the author attempts to use a rather creative mapping of a complex mathematical concept here to prove why only certain resonances are stable. They reference the Mordell conjecture, which was proven by Klaus Faltings and is known as Faltings' theorem.
But wait, I want to bring up the friction in the source material here, because the AI that the author was using as a sounding board actually pushes back hard on this specific mathematical mapping.
It does, and the AI's pushback is illuminating. The AI points out that Faltings' theorem is a very highly specific tool from algebraic geometry. It deals with rational points on curves, essentially two-dimensional mathematical constructs. The AI argues that you cannot easily map a theorem about 2D rational curves onto the physical behavior of 3D spherical resonance structures in the real world.
It's a leap. You can't use flat math to prove spherical physics. But the author's response is really telling. How do they handle that critique?
The author essentially says, fine, keep the math, I'm focusing on the physics. They clarify that they are separating the physical mechanism from our current mathematical tools.
Oh, okay.
The physics, the emergent behavior of the universe dictates that this 3D instrument acts as a filter, where only a finite number of stable resonances can survive the chaotic churn of the void.
And this is the mind-blowing part.
Yeah.
What we currently call fundamental particles, like an electron or a quark or a proton, the NKE says these are not tiny, solid billiard balls flying through empty space.
No, they are just the stable, standing 3D vibrations, the distinct notes that are allowed to exist within this Busfo instrument.
It is a beautiful, elegant way to unify matter and energy. Everything is just a vibration of the underlying network. But I have a massive problem with this, and it's a question the AI in the source material actually asks the author directly.
Right.
If this Busfo process is so incredibly simple, just a continuous engine-making structure, and the instrument it creates is so stable, why isn't the universe just a perfectly smooth, boring, uniform soup?
Right.
We know the underlying network is uniform because we can measure the cosmic microwave background radiation, and it's incredibly smooth at 2.732 Kelvin in every direction.
Yes.
If the underlying rules are that simple and smooth, why do we have highly complex, clumpy galaxies, chaotic star formations, planets, and massive empty voids?
That is the ultimate quantum of emergence, and the author's response is fantastic. He essentially asks, are you serious? Have you never heard of the butterfly effect? Do you know John Conway's Game of Life?
Let's dive deep into the game of life because I think it proves the point perfectly. For listeners who haven't played around with it, remind us what it is.
It is not a board game. It's a zero-player mathematical simulation developed by mathematician John Conway in 1970. It is the most famous example of a cellular automaton. Imagine an infinite, two-dimensional grid of square cells, like a massive piece of graph paper.
And each cell can only be in one of two states, alive or dead, black or white.
And there are only a few incredibly simple, rigid rules that govern the grid, based on how many living neighbors a cell has. If a living cell has fewer than 2 live neighbors, it dies of underpopulation.
Okay.
If it has more than 3, it dies of overpopulation. If an empty cell has exactly 3 live neighbors, a new cell is born.
That's it. Those are the only rules. It's incredibly basic.
But if you seed that grid with just a few random living cells and let the simulation run, what happens?
It goes crazy. It doesn't just sit there. The cells start pulsating. They form structures that look like spaceships called gliders that literally travel across the grid. They form guns that continuously shoot out other structures. You get endlessly complex, emergent, migrating patterns that you would never be able to predict just by looking at the simple rules.
Precisely. The author is using the game of life to argue a fundamental truth about reality. Simple rules, combined with tiny initial fluctuations run through infinite iterations of a self-reinforcing process, will inevitably lead to massive emergent complexity.
Simple rules plus time equals galaxies. The Busfo process is the simple rule. It's the DNA of the universe. It doesn't need complex instructions to build a galaxy. It just follows its basic mandate of structure formation over and over, and galaxies emerge naturally.
And once you understand how this engine works, you have to accept the new rules of reality it dictates. Let me tell you, these new rules completely shatter the old patchwork models we were forced to memorize in high school.
Let's talk about those rules. This brings us to the core mantras of the NKE, the philosophy that arises from the Busfo process.
The primary mantra, the philosophical bedrock of the NKE, is a German phrase, Struktur im Nichts fast, Struktur in nichts an. Structure in the void touches structure in the void.
Structure touches structure. It sounds almost poetic, but what are the actual physics implications of that statement?
It means there is no magic in the universe. There is no process that takes something and turns it into something fundamentally different. Everything, absolutely everything that exists, is just structure interacting with other structure.
So no magical transitions or invisible underlying ethereal substances?
None. The sources refer to this as relativity on steroids. Einstein said space and time are relative. The NKE says everything is relative.
Because there are no fundamental, indestructible, solid particles.
Right. What we think of as a particle is just a complex resonance cocktail. It's just a pattern of structure vibrating as a neighboring pattern of structure.
And this leads to one of the most paradigm-shifting consequences of the NKE framework, the complete elimination of spooky action at a distance.
Well, this is a big one.
Okay, let's break that down because this is where traditional physics gets very weird. In traditional physics, you have concepts like quantum entanglement, where you can separate two particles by thousands of miles, flip one, and the other flips instantly, or even classical gravity.
Yes, think about gravity. Traditional physics tells us that the sun is somehow reaching across 93 million miles of completely empty space, grabbing hold of the Earth and keeping it in orbit.
It implies an invisible tether, like an invisible force acting instantaneously across a massive void.
The NKE says absolutely not. There are no remote forces, none. All phenomena, from entanglement to gravity, are the result of local direct interactions between adjacent structures. Structure touches structure.
But wait, I have to stop you there and push back.
Okay.
If there are no invisible tethers, if gravity isn't a warping of a space-time fabric or a magical pulling force, how on earth does the NKE explain gravity pulling me to the floor right now?
The author describes gravity as a Mitzi effect, a pull or drag effect of the structure itself.
How does that work mechanically?
Let's use a tangible analogy. Imagine you have a massive pot of very thick, viscous soup on the stove. If you stick a large spoon in the center and start stirring rapidly, what happens to the soup near the edges of the pot?
Even though the spoon isn't touching the edges, the soup at the edges starts to swirl inward, following the motion. The center drags the rest.
Exactly. Because the soup has structure and viscosity. The NKE posits that as the Busfo process continuously builds and reinforces structure, areas of massive density, like a planet or a star, are essentially stirring the pot.
Wow. Okay.
They are highly active nodes of structure formation. Because structure touches structure, this massive, dense area physically pulls and drags on the adjacent, less dense structural network around it.
So gravity is a localized structural drag that scales up to look like an attractive force?
Yes. The Earth isn't reaching out to grab the Moon. The Earth is creating a massive, localized structural drag, and the Moon's structure is caught in that cascading adjacent pull.
But wait, if it's like stirring thick soup, wouldn't there be immense friction? Shouldn't the planets just bleed off all their energy and spiral into the sun immediately?
That's where the concept of resonance comes back in. The planets aren't solid objects pushing through a separate liquid. The planets in the soup are made of the exact same underlying Busfo network.
Right.
The planet is just a localized wave of complex resonance traveling through the network, like a sound wave traveling through water. The structural drag dictates the path of the wave, but it doesn't necessarily impart the kind of kinetic friction a solid object would experience.
Okay, that makes an intuitive kind of sense. It grounds it in mechanical reality. But what about the strong nuclear force, the thing that holds the nucleus of an atom together? Traditional physics says it's the exchange of particles called gluons. We literally invented a particle just to explain why atoms don't fly apart.
In the NKE, the strong nuclear force is stripped of its need for magical exchange particles. It is redefined simply as the structural integrity of a resonance.
Explain that.
Remember the guitar string. If a particular 3D resonance pattern is incredibly stable, a perfect note in the Busfo instrument, it takes a massive amount of external energy to disrupt or alter that structure. What physicists measure as the strong force holding a proton together isn't a tiny glue particle. It is simply the immense energetic threshold required to shatter that highly stable 3D vibration.
It's just structural integrity. Structure touches structure. I see how this unifies the micro world. We've looked at the microscopic DNA of the universe, the NKE, the Busfo process, the stable resonances, the structural drag of gravity. But now I really want to look at the living organism it grows into on a cosmic scale.
We're moving from the micro to the macro.
Exactly. And this forces us to look at the second half of the author's framework, the small bang theory, or SBT. Because if gravity is just structural drag and everything is continuous formation, how did this all start?
If you thought redefining gravity was bold, the SBT takes on the origin of the universe itself. The sources reveal a claim that completely rewrites modern cosmology, and it is the punch-to-the-face concept we open the show with.
The Big Bang is an illusion.
Yes.
I can hear the high school science teachers hyperventilating. No Big Bang. It's the cornerstone of astrophysics.
Let's clarify. The universe is expanding. We can observe the red shift of distant galaxies. That part is undeniable.
Right.
But the traditional narrative that the universe exploded outward from a single infinitely dense, infinitely hot point in space roughly 13.8 billion years ago, the SBT says that is mathematically and physically flawed.
Why?
Because according to the NKE, the Busfo process, the engine of structure formation, is happening everywhere, all at once, infinitely fast.
Okay.
Therefore, there is a continuous spherical expansion occurring at every single point in the network simultaneously.
Let me make sure I'm picturing this right. The universe isn't a balloon expanding into an empty room from a central point. Every single point on the balloon is expanding itself, continuously.
Yes. And because every point is expanding locally, when you observe the macrocosmos, everything appears to be rushing away from you, no matter where you are standing.
Wow.
The impression of a single ancient Big Bang originating from a central point is just an optical illusion created by the global dynamics of this everywhere happening process.
That is a massive paradigm shift, but it solves so many problems. Let's take dark matter. In traditional physics, scientists are currently spending billions of dollars building massive underground detectors, looking for an exotic, invisible ghost particle to explain why galaxies hold together.
Right.
The outer edges of galaxies spin too fast. There isn't enough visible mass to generate the gravity needed to hold them together based on Newton's laws. So we invented dark matter to make the math work.
And have they found it?
Decades later, absolutely not a trace.
Because according to the SBT, dark matter isn't a particle at all. It is simply an early stage of the self-reinforcing structure formation.
Hold on, I'm going to push back hard here.
Do it.
You can't just say dark matter is young structure. Dark matter exerts immense gravitational pull. If it's just structure that hasn't fully formed yet, if it has no mass, how does it exert gravity?
Remember our new definition of gravity. Gravity isn't reliant on mass as a fundamental property. Gravity is the Mitzi effect structural drag.
Ah, of course.
As the Busfo process churns away in the void, it starts building network density. Even before this structure achieves the highly complex, tightly wound 3D resonances that we perceive as visible matter or light, it is still structure.
Right.
It's still a thickening of the soup. Therefore, it exerts a structural drag on the adjacent network.
So it has the pull of gravity, but it hasn't formed enough dense, complex resonant structures to emit a photon yet. It is literally just the invisible, dark scaffolding of the universe being built right in front of us.
It is incredibly elegant. It doesn't invent a new magical particle to fix a broken equation. It just relies on the same fundamental rule: structure touches structure.
But the SBT goes even deeper into redefining reality. It redefines the very stage upon which this all happens: space and time. Space isn't a pre-existing empty box where the universe was placed.
Exactly.
The sources state that the Virgin Busfo network has no spatial properties whatsoever.
This is a profound concept of emergence. Space is a consequence of structure, not a container for it. Without structure, there is no distance.
So there's no here or there.
Right. Spatial dimensions only emerge as the network gets denser and begins to interact with itself.
Okay, I can almost wrap my head around space emerging from structure. But time, the text says time emerges before space via a tiny symmetry break in the fundamental process.
Yes.
Stop. We need to go incredibly slow here. How do you have time emerge before space? How do you have time without a physical place for time to happen in?
Let's strip away our human obsession with clocks and calendars. What is time? Fundamentally, at its absolute core.
It's a sequence. It's things happening one after another. It's cause and effect.
Bingo. Causality. Now imagine the Busfo process in its absolute most virgin state. Just an infinitely fast oscillation of structure forming and dissolving. If it is perfectly 100% symmetrical, nothing ever truly changes.
Right.
It just pulses in perfect equilibrium.
Like a frozen vibration.
Exactly. But the text posits a tiny symmetry break, a microscopic flaw in the perfection of the process. The moment that symmetry breaks, the structure changes state permanently. You suddenly have a state A that led to a state B.
You have a cause and an effect.
Exactly. This symmetry break creates a structural difference, which allows for the very first instance of a before and an after.
But the crucial detail the author emphasizes is that this before and after has no units. There are no seconds, no minutes, no ticking cosmic clock governing the universe. It is simply the origin of sequence.
Time is just the sequence of structure changing. It is built into the engine, but it is unitless. And because this symmetry break and structure formation process is continuous and ongoing everywhere, the universe isn't a product of one massive ancient Big Bang. It is filled with continuous small bangs.
Hence the small bang theory.
The author likens these small bangs to the ongoing formation of solar systems, quasars, and stars. The self-reinforcing structural pull creates local concentrations of extreme density happening all the time, all over the cosmos.
The universe is a perpetually boiling pot, not a firecracker that went off once.
Exactly.
It is a totally unified picture. From the microscopic resonance to the macro small bangs, it's one cohesive story. But I have to admit, taking all this in synthesizing structural drag, emergent space, unitless time, and continuous creation requires a massive cognitive leap.
It really does.
It's hard to hold all these new concepts in your head at once without feeling like your brain is going to short circuit.
It is cognitively exhausting.
Right.
Which is why I appreciate that the author actually includes a psychological framework for how to think about this kind of complexity.
Right.
They don't just hand you the physics, they hand you a tool for processing it.
Right.
It's called the SUMP model, the swamp model.
The swamp model. I love this analogy. Let's walk the listener through it. Imagine you are literally standing on the edge of a deep, murky swamp. You need to find a path across to the other side. This swamp represents a complex, multivariable problem, like a theory of everything.
Now, human cognition has limits. Our working memory can only hold about 7 complex association chains at once.
So imagine those 7 association chains are wooden planks. You carry them to the edge of the swamp, you throw them down on the mud, you step out onto them.
Right.
You walk back and forth on these planks, testing connections, looking for solid ground, trying to logically link a thought about emergent time to a thought about structural drag.
But you are in a swamp. The mud is unstable. Eventually, as you try to juggle these massive concepts, the planks begin to sink.
Yeah.
You lose your train of thought. The mental model collapses under its own cognitive weight, and you slip into the mud.
Yeah.
You have to retreat, gather new planks, and start over from a slightly different angle.
The SWARP model acknowledges that building, or even comprehending, a theory of everything requires immense mental discipline. It's not a sudden eureka moment in a bathtub. It's the grueling process of constantly rebuilding pathways, failing, sinking, and trying again.
It perfectly describes the frustration of learning something truly new and paradigm shifting. You have to be willing to get dirty.
And this brings us to a fascinating detour in the sources regarding artificial intelligence, because we are in an era where we use AI to help us think. The author used an AI, specifically large language models, as a sounding board while developing these theories.
We talked earlier about the AI pushing back on the math.
Right.
But the text is very clear about the limits of LLMs when it comes to navigating the swamp. LLMs are incredible pattern matching engines. They can synthesize massive amounts of text and mimic logical deduction. But the author notes they fail at true, multi-scale emergent physics for two critical reasons.
Okay, let's hear them.
First, they lack a stable internal worldview.
What does that mean in this context?
An AI doesn't understand physics. It doesn't have an internal engine simulating gravity or time. It is merely predicting the most statistically likely next word based on its training data. It can sound incredibly convincing while being physically absurd.
It's an illusion of understanding.
And second, LLMs suffer from context compression.
Right. When you feed an AI a dense, 97-page, highly complex physics paper, it has to compress and summarize that information to process it within its memory limits.
Yes.
In doing so, it smooths out the edges, it loses the tiny nuanced details, the subtle symmetry breaks, the self-referential logic, the specific mechanism of the Mitzi effect that are absolutely crucial for a theory of everything to hold together.
An AI can't hold the 7 planks in the swamp. It just averages out the mud and tells you it's a solid road.
It is prone to hallucination when pushed to the absolute limits of foundational logic. However, the author does not dismiss AI entirely. In fact, there is a direct challenge issued to you, the listener, in these sources regarding how to use AI.
I found this part so engaging. The author acknowledges a hard truth. 99% of people listening to this or encountering this theory will never sit down and read a dense 97-page scientific paper with 500 pages of supplemental notes.
It's just not how modern consumption works.
Right.
I know I wouldn't casually read that on a Sunday afternoon. So the author offers a challenge. Don't just passively consume this information. Don't just take my word for it. Take the author's paper. The link is provided in the source notes, rxiverse.org-, and load it into your favorite AI.
Use the AI to help you navigate the text. Ask it questions. But don't treat it as an oracle. Treat it as a sparring partner.
Challenge the AI to find contradictions. Prompt it by saying, explain how the NKE defines the strong nuclear force without particles, or debate the concept of the small bang continuous expansion against the cosmic microwave background.
Yes.
Use the AI to stress test the planks in your own mental swamp.
Become an active co-researcher. This active questioning mindset is exactly what we need to bring this entire deep dive full circle back to our starting point, the classroom.
This is the crux of it all. This is where the practical application of the SBT and NKE truly shines. If we actually have a unified, logical model that explains reality from the smallest void resonance to the largest galaxy without contradicting itself, how do we use it to fix the broken patchwork educational system we suffered through?
Well, the author lays out a specific proposal for an alternative curriculum, and it's incredibly smart in how it phases the cognitive load.
How so?
You don't start with the heavy, mind-bending NKE void physics. In grades 7 and 8, you introduce the macro view, the small bang theory.
It makes perfect developmental sense for a young teenager. The SBT is highly intuitive. You teach 13-year-olds that the universe is just a continuous process of structure building. You teach them that dark matter isn't some spooky ghost particle, it's just early-stage structure.
And most importantly, you show them that the formation of the Earth in geology class and the formation of the universe in astrophysics class are driven by the exact same fundamental rules. The Earth's accretion disk is just a localized small bang. It's an easy-to-grasp cosmological model that replaces the fragmented, isolated theories they usually get.
Then, once they have that intuitive macro picture of continuous creation, you introduce the deeper microscopic physics, the NKE, the Busfo process, the emergent properties of space and time in grades 10 through 12. You show them the engine under the hood.
But the absolute most brilliant part of this educational plan, the thing that would truly revolutionize how kids learn and think, is the proposed testing model.
Yes, the power of choice on exams.
Exactly.
The author proposes that students are given parallel questions on a physics test. They can choose to solve a problem using the traditional standard model, or they can choose to solve it using the NKE framework.
Imagine a high school test that says, Question 3, explain the mechanisms of gravity. Choose path A, general relativity, or path B, NKE structural drag.
And the grading is fundamentally different.
Yeah.
You aren't graded on your rote adherence to the scientific status quo. You aren't penalized for rejecting the textbook. You are graded purely on your internal logical consistency.
Yes.
Can you build a coherent argument? Can you apply the rules of the framework you chose to arrive at a logical, defensible conclusion?
This breaks the obedience cycle. The traditional curriculum forces students to accept disjointed theories without seeing the big picture. It demands, as we said, shut up, accept, and memorize.
Right.
But teaching the SBT and the NKE shows students that reality is a cohesive, connected story.
And I want to apply this directly to you, the listener. Think about how you were trained to view problems at your job, or in your relationships, or in your life. You were likely taught the standard model of life. Memorize the rules, stay in your lane, don't ask why things are broken, just calculate your way through the day.
Wow. Yeah.
This proposed curriculum change isn't just for 7th graders. It's a blueprint for how you can start attacking the swamps in your own life.
It replaces the demand for obedience with the joy of complete comprehension. It tells the student or the adult, your underlying intuition that things should make sense, you were right.
Exactly.
It uses physics not just as a transfer of historical facts, but as a crucible to build critical thinkers.
It proves that you don't have to be a hyper-specialized academic with a massive grant to look at the universe and demand that it makes logical sense. The SBT and NKE aren't just concrete answers to unsolved mysteries of dark matter or gravity. They are the intellectual fuel needed to reignite curiosity.
They give us permission to ask why again.
It is a remarkable synthesis of physics, philosophy, and pedagogy. And amidst all the complex mechanics and educational theory in the sources, there is a beautifully human note the author leaves us with.
Oh, I'm glad you brought that up.
Share it with us.
The author includes a quote from the Austrian writer and playwright Arthur Schnitzler. In the end, only what we have done and lived counts, not what we had planned.
That is incredibly powerful in this context.
It is the ultimate validation of the author's pragmatic approach. It's a reminder that publishing an imperfect truth, putting a temporary absolute truth out into the world and acting on it, letting people debate it and tear it apart, is infinitely more valuable than quietly planning a perfect, unassailable, mathematically flawless theory that never leaves your notebook.
You have to step into the swamp. You have to lay down the planks. You have to do the work.
Go.
So let's recap this incredible journey before we go. We started by looking at a physics establishment stuck in a pragmatism of shut up and calculate, terrified of career suicide. We saw how the author used the pragmatic detective work of the NKE to find the prime suspect, the Busfo process.
And we explored how simple rules create massive complexity.
We examined the continuous creation of the small bang theory, shattering the illusion of a single Big Bang and redefining gravity as structural drag.
And we ended with a vision for a classroom, and really a life where questioning is rewarded over memorization.
But speaking of doing the work and stepping into the swamp, I want to leave you, the listener, with one last thing to ponder.
A final thought.
We talked deeply about how in the NKE, time itself emerged not as a ticking clock, but simply as a microscopic symmetry break. It created a unitless before and after based entirely on structural change. If time is truly just the sequence of structure changing and there is no universal clock, what does that mean for how you experience the present moment right now?
It's a profound shift in perspective.
Are we just complex resonance cocktails riding the crest of an eternal, everywhere happening process? If time has no units, then the present moment is simply the act of change itself. Don't just accept the tick-tock of the clock, keep questioning.